Hi, I am going to introduce three types of KUKA robot motions, which are PTP, linear, and circular. What is point-to-point? The PTP motion. When PTP motion is applied for the path from P1 to P2, the tool center point, the TCP, will follow the fastest possible path instead of the shortest path. Based on the figure, yes, the solid line instead of dotted line. Well, next, we would like to talk about the linear motion. When linear motion function is applied for the path from P1 to P2, the TCP follows linearly and directly from P1 to P2 in a line. In another word, it goes with a straight line, and we can say that is the shortest path from P1 to P2. Other than PTP and linear motion, robot TCP can follow a circular path with circular motion function. The circular path can be defined by 3 points, which are start point, auxiliary point, and end point. The robot TCP will follow the path from start point to end point, passing through auxiliary point with a circular pattern.
Now, let us talk about approximate positioning function. Approximate positioning actually means that the motion does not stop exactly at the programmed point. Approximate positioning is an option that can be selected during the motion programming, for example, PTP motion, linear motion, and circular motion.
The PTP motion function with approximate positioning. The TCP leaves the path that would lead directly to the endpoint, and moves along a faster path. During programming of the motion, the maximum distance from the endpoint, at which the TCP may deviate from its original path, is defined. The path of an approximated PTP motion cannot be predicted. It is also not possible to predict which side of the approximated point the path will run. The same concept goes to the linear motion function for approximate positioning. For circular motion, the accuracy of the program path will stop at auxiliary point from start point, while the endpoint is approximated. By the way, the path in the approximate positioning range is not an arc.
Hi guys, now the first step is, let us create a new file. New. So we simply type component. One. Okay. So this component one, and we open. So here is the original one. We created line 4, so we need to program for this contour. So this is the data. We need to go from this data to this point and around this point up to this again. This is the home position. So first of all, we need to go to the point. Access. Okay. A5 plus okay. Then motion point to point. Okay. So then we go to the return. First of all, need to go from the base. Okay, the base. Okay. So now X. So we reach the point. Okay. So motion point to point. Okay. So now we need to go from this point to that point. It's the same. Y axis Okay, now motion, here we choose linear because it is linear line. Okay, so now basically it is a curve. So this is another program. We go like this. We go to the point. Okay, here we go motion. We choose circular. At circular here, we teach parts. Okay, then we add here without closing it. We go to another point. The end point. Okay, here we teach end. Okay, yes. Then okay. So here basically is the curve command. So after that, there's a linear again, curve, linear. That's all the same. Okay. Okay. Now we finish our programming. So from the datum around the contour and back to the datum again. Here is the final one. So now we need to change our velocity. You can see here. We click on the line. We change. We need a 0.3. So basically it is 2. Original is 2. We change to 0.3. Okay. All is the same. We change all the line, all the velocity to 0.3. Okay.
Yeah. So inside the KUKA controller, we can see there are 3 options, including the T1, manual reduced velocity, T2, manual high velocity, and also the automatic. So what are the difference between them? As you can see, normally T1 is using for the test operation, programming, and teaching, but T2 is only for the test operation. And for automatic, normally is it's used for the industrial robots without a higher level of controllers. Now we're going to see how T1, T2 and automatic works when the KUKA robots works. Now, according to this, the robots will go to this datum. After that, you will go straight and along the arc. So this is under the T1 mode. T2. Okay, as you can see, T2 normally, since after we change the velocity, it will be slower than the T1. So it will like travel at 0.3 meter per second. So now we're going to run the KUKA robot in the auto mode.
I will start to explain the approximate positioning. The main is how we're going to change the sharp corner into a curve. This is the number line. Change the corner to the in a curve. So for the command, circular P3. We select the circular P3 first, then change, then the continuous. And for the approximation parameter, we select and change the approximation distance. The original is 100 and we change to 140. This is based on try and error to match the curve line. So for the next continuous is linear P12. same state is applied, change the continuous and also change the approximation distance. So now I will show you how the program runs. As you can see, the sharp corner is becoming curved motion now, as is because the continuous command. And another continuous command applied.
my images how we show the approximate in the T1 way. Right now I will change it into T2. Okay. As we can see that the KUKA robot is starting moving, but the speed is remain the same at 0.2. It's difference at times where it is in T1 way. You can see that the KUKA robot right now, the previous way the KUKA robot is moving in the sharp way, but right now it's moving in the curved way. Now it's come to another sharp corner, but the KUKA robot moves in the curved way as we.
Alright, now I'm going to do some advanced applications introductions. First of all, I will be introducing on the knowledge of switching functions and the pulse function and also complementary switching. And we are going to use basically 5 logic commands, which is wait for, out, synchronize out, and also synchronize out. Okay. As you can see from here, we already edited the file into what we wanted by using the logic commands. As you can see here, it's a wait command. So basically, a wait command is to tell the KUKA robot to wait, for example, 5 seconds. And another one is the logic command wait for. So basically, this wait for is to telling the PLC to issue an enabling signal on the input 11. And another one is also out. The meaning of out is output 12, which means I'm telling the PLC to issue an enabling signal on the output 12 signal. So another one is synchronize out, which means by the time of output 12 enabling, we are going to enable another output signal, which is 13. Okay, let's see what's the function of this file with the logic commands. As you can see, now it's a wait logic command, which is going to wait for 5 seconds before it moves to the next point. So now at this point, we already set a logic command wait for, which means that I need an input, an input 11 to enable it before we can proceed to the next move, which is I need to switch on the switch over here. Now it continue its movement. So at this point, it's a P5 linear motion. The output 12 will be enabled, and at this point, it's going to delay for 5 seconds just now. So now the KUKA robot continue its movement. So basically now the output 12 and output 13 will both be switched off, and the KUKA robot will return back to its home position. That's all for the passive applications for me. Thank you.